Okay, BIDMAS stands for brackets, indices, division, multiplication, addition, subtraction. And BIDMAS is very important in algebra because it tells you the order of importance of these various operations. So you always have to think about BIDMAS when you're evaluating expressions. Okay, let's do some examples. Let's start with x is 3y plus 4. Okay, now if you're handed that expression, they may tell you something like evaluate this when y equals, I don't know, 2. Okay, so that means you have to substitute in 2 into this expression here. So therefore x equals 3, always use brackets when subbing in, okay, like that. It's 3 times y, it's 3 times 2, but use brackets because y is 2 plus 4. Okay, now this is where BIDMAS comes in, because do you add the 2 to the 4 and then multiply by 3, or do you do 3 times 2 and then add the 4? Well, BIDMAS tells you brackets, indices, division, multiplication. The 3 is multiplying the 2. Multiplication is more important than addition, okay? And therefore you do the multiplication first. It's 3 times 2 plus 4. In fact, I'll write it like that. X is equal to 3 times 2 plus 4. Okay? So because of BIDMAS, the multiplication beats the addition. So we have to do that first and then add the 4. So therefore, x is 3 times 2 is 6 and then add the 4. So therefore, x is 10. Okay? And that's why BIDMAS is important. You'd get a different answer if you added the 4 first. And I'll prove it. Watch this. Okay? X is 3 times 2 plus 4. What if it's written like this? 3 times 2 plus 4. Okay? What if it just so happens that they've written the 2 and the 4 and the plus all close together, and they've left more space here around the times? They might be trying to trick you. Okay? Don't fall for it. That and that are exactly the same thing. I know it looks tempting to add the 2 and the 4 together first, because look, they're so close together. But don't fall for it. Multiplication still beats addition in BIDMAS. So you have to do 3 times 2 first. If you did the 2 and the 4 first, you get 6 times 3 is 18. So if you do the addition first, you get x is 18, which is clearly not the right answer because 18 and 10 are different. So don't fall in to that trap, okay? Right, let's do another one. Let's do a is b squared over 2. Why not? Okay, a is b squared over 2. And let's say we have to evaluate this when b is 3. Right. So, first thing to do is sub in value 3 to b into there. So therefore, a is, always use brackets when subbing in, 3 squared over 2. Okay? So, we have an indices. So indices comes in. And brackets is ahead of indices. The brackets, being the most important of all, means sort out everything inside the bracket first. So we don't need to do that here because everything inside the bracket is sorted. it's 3. It can't get any more simple than that. Okay. So next is indices. That means squaring, cubing, that kind of thing. That's an index. So we have to evaluate the index thing first before dividing by 2, because division comes up lower than indices. So therefore we have to do 3 squared first, do the index thing before the division by 2. So the correct answer is A equals, do the index first because it beats division, 3 squared is 9, and then divide by 2. So therefore A is 9 over 2 is 4.5. Okay? Again, if you'd done the division before the index and you did 3 divided by 2 and then you squared, you get 3 divided by 2 is 1.5. If you square that, it's 2.25, which is not 4.5. So BIDMAS is important. Right, let's do another. Let's do P equals 3 times q minus 1 cubed when q is 5. Q is 5. Okay, so we have to evaluate that expression when q is 5. Let's do it. Therefore, first thing to do is sub in. P is equal to 3 brackets. Always use brackets when subbing in. Q is 5. 5 minus 1 cubed. I know it looks like there's a lot of brackets, but don't worry about it. Trust me, always use brackets when subbing in. Therefore, P equals, right, brackets is the most important thing of all in BIDMAS. So we have to simplify everything inside this big bracket first. So we've got 5 minus 1 inside these brackets. We can remove these brackets first because there's nothing in front of them multiplying it or nothing else to do with it. So we can just write that as 5 minus 1. All we're doing is removing those brackets. So therefore, P is, right, we still haven't finished sorting out the brackets. We have to simplify this. 5 minus 1 is 4. Okay, we've dealt with brackets. Next is indices. So P equals, there's the indices bit, it's 4 cubed. And then we multiply by 3 afterwards because multiplication is lower. So we do 4 cubed first. Well, 4 cubed, 4 times 4 is 16, times 4 again is 64. So 4 cubed is 64. So therefore, P is equal to 3 64s is 192. Okay? Good. Let's do some more examples. Okay, next example. T is minus u squared when u is 7. Okay? So, sub in. T is minus, always use brackets when subbing in, 7 squared. Right. BIDMAS. That minus there, it's like when you have a minus next to a bracket, it's like there's an invisible 1 there. It's like minus 1 times the bracket, okay? So that is a multiplication. And that is an index, an indices thing. And that wins. In BIDMAS, indices comes before multiplication. So we do 7 squared first. So therefore, T is minus, What's 7 squared? 49. And now we can do the minus 1 times 49. So t is equal to minus 49. Okay? Next, let's do v is minus w all squared. And I'll do it here. v is equal to minus w all squared when w is 4. Okay? Comma w equals 4. Right. So these are different because the brackets here surrounds the minus as well. So it's important to realise that these are two different types of expression. Okay, sub in the value of 4. V is equal to minus 4 squared. Okay. Therefore, v equals, well, there's nothing more we can do with that bracket. BIDMAS brackets is the most important thing. So we can evaluate the big bracket and simplify everything inside the big bracket. And that means we have to do this minus 1 times the 4. So minus 1 times 4 is just minus 4. Okay, so we've got rid of the little brackets, now just the big ones, the ones up on the outside, left. So, therefore, v equals, it's minus 4 all squared. That means it's minus 4, okay, times minus 4. It's not minus 4 squared. Like I said, these are different. So minus times a minus is a plus, and 4 times 4 is 16. Okay, good. Let's do another. Right. So, what if you have something simple like x equals 3y, when y is 6? Okay, well, you just sub in the value, x equals 3 times 6, so x equals 18. Nice simple one there. Right, let's do another simple one. P equals q cubed. P equals q cubed. When q is, yeah, it's minus 4. Okay, therefore P is q cubed, and q is minus 4, so it's minus 4 all cubed. And this is why, I know I keep banging on about always use brackets when subbing in, but this is exactly why you should do that. Okay, if you didn't use brackets, you might write this, minus 4 cubed. And exactly because of BIDMAS, these two things are different. Okay, in this case you do 4 cubed and then minus it. In this case you do minus 4 cubed. And yes, by pure chance those two happen to be the same thing, but generally, I mean, they evaluate to the same thing. Mathematically they're not technically the same thing. My point is that often they'll evaluate something different. Okay, always use brackets when subbing in. Okay, so therefore minus 4 times minus 4 times minus 4, it's a minus times a minus, which is a plus, times another minus, which is a minus. Okay, 4 times 4 is 16, times 4 is 64. Good. Right, let's do, A is 3 times t minus 6 all squared, when t is 9. Okay, evaluate that when t is 9. No problem. Therefore, a is 3 times 9 minus 6 all squared. Okay, therefore a is, well, brackets first. We have to sort out what's inside the big brackets. So we can remove those little brackets because there's nothing else happening to that. So it's just 9 minus 6, which is 3 squared. Okay, therefore a equals, indices beats multiplication. So we do the index first. So we do 3 squared first, which is 9. And then we do multiplication. A equals 3 nines, which is 27. Good. Right. Let's do one more here. Okay. Right. Let's do evaluate 2b squared over 3 minus a when b is 3 and a is minus 6. Okay? So, right, I'm going to write that equals, and then I'm going to write whatever that equals after I've subbed this in, which is slightly different in style to the way I've been doing it. I just want to clarify so there's no confusion. That's an equation because there's an equals sign. That is not an equation. There's no equals sign anywhere. Okay? These are not really equations. That's just telling you what the value of b is and the value of a is in this instance. But that is not an equation. It's just an expression. And therefore it's okay to write an equals there and then whatever that value is when I put these in here, because that does indeed equal that. But here, I can't write an equals there. It's much better to write a therefore, because if you're separating one equation and then you're writing another equation and another and another and another, you should separate the equations by therefore, but it's okay to link expressions by equals if you're evaluating them. Okay, let's just get on with it. So this expression equals, let's sub these values in, 2b is 3 squared over 3 minus, brackets to sub in, a is minus 6. Okay? So that equals, no need to rush. Let's leave the top alone for the moment. Okay? And just deal with the bottom. We have a minus. Okay, firstly the bracket, BIDMAS, brackets first. We can't simplify the contents of that bracket anymore. Minus 6 is as simple as it gets. So, we can therefore multiply out that bracket. Do the multiplication. Like I keep saying, if you have a minus next to a bracket, there's an invisible 1 there. It's like minus 1 times the bracket. So, BIDMAS, the multiplication of that minus 1 by the bracket, multiplication beats addition subtraction. There's a subtraction, it's 3 minus something. So the multiplication wins, so we do the minus 1 times the minus 6 first. So minus 1 times minus 6, minus times a minus is a plus. So it's 1 times 6 is 6. Right? So that equals, let's get rid of that, 2. I'm not doing anything at the top yet, just worry about the bottom. 3 plus 6 is 9. Right. Now we can start worrying about the top. So, BIDMAS, indices beats multiplication. So we do the indices first. So we do 3 squared first. So 3 squared is 9. All over 9. Okay, so it's 2 times 9 divided by 9. We can cancel the 9s, and the final answer, it just evaluates to 2. Good. Right, now, let's make sure there's no confusion here. In BIDMAS, indices beats division, multiplication, addition and subtraction. So why was I allowed to start evaluating the multiplication and addition here on the bottom before I even went near the index on the top? Well, that's a good question. And I think the best way to explain it is, if you had targeted the 3 squared first, then that would have been fine, because you'd still get 2 times 9, 18 on the top. And then if you evaluated the bottom, you'd still get 9 on the bottom. So you'd end up with 18 over 9, which is 2. You'd still get the right answer. But it's okay to leave that alone and do the bottom first, because the top and the bottom of this expression, you can treat them separately, okay, until you're down to the point where it's simple enough for you to evaluate it and get the final answer. I suppose what I'm saying is you're applying BIDMAS individually to the top and the bottom, okay? So it's okay to not do the top, to evaluate the bottom first, even if there's an index in the top, because you're still applying BIDMAS rules to the bottom. When we evaluated the bottom, we applied BIDMAS, and when we evaluated the top, we applied BIDMAS. But because they're separate, it doesn't matter the order which you do them. I hope that's clear. But you notice what we did do. We did evaluate the index expression before we divided. This big dividing, the 2 times 9 divided by 9, we had to evaluate the index thing first before we divided, because at this point we had to worry about both at the same time, and BIDMAS, the index beats the division. Right, let's do 2 more expressions and call it a day. Let's do 8x squared minus y squared. We're going to evaluate that when x is minus 5, okay, and y is minus 2. Right, so again it's an expression, so we can write equals 8x is minus 5 squared minus y is minus 2 squared, right? And that equals, okay, again a minus and a bracket, so there's an invisible 1 there. It's minus 1 times that. So that's a multiplication, and BIDMAS, the indices, the index beats multiplication. So let's just not worry about that yet. Let's do that. So that's the same as -1 times -2 squared. That's -2 times -2, which is +4. Okay, which is equal to -5 squared. -1 times 4 is -4. Okay, let's do this bit. Again, 8 times this, that's a multiplication, and that's beaten by the index. So we have to do the index, evaluate the index first. -5 times -5, that's -5 squared, is +25. Okay, right, we've got 8 times 25, and then a subtraction, -4. BIDMAS, multiplication beats the subtraction. Subtraction is at the bottom of the pile. It's the S on the end of BIDMAS. So we do the multiplication first. 8 times 25 is 200 -4, which is 196. Boom. Good. And the last one. I think this video is long enough. Let's do y minus 3 times x plus 1 squared. All right. And let's evaluate that one. Y is 7 and x is -4. Okay. So that expression equals y is 7. 7 minus 3. X is -4 plus 1. All squared. Okay. Good. So, BIDMAS, B. Most important thing is brackets. We need to sort out what's inside this bracket and what's inside this bracket before we multiply the two brackets together. So, let's sort out this bracket. 7 with a bracket around it. Well, we can remove the brackets because 7 with a bracket around it and nothing in front is just 7. Okay, it's +7. So that's 7 minus 3. This bracket here, again, we can remove the small brackets. It's just -4 plus 1 squared. Okay? BIDMAS, brackets, most important thing. We don't do any indices or multiplication yet. We still haven't sorted out the brackets because that bracket can be simplified and that bracket can be simplified. So this bracket can be simplified. 7 minus 3 is 4. This bracket can be simplified to -4 plus 1 is -3 squared. Okay. Now we've got a multiplication, this times this, and we've got an index. And again, BIDMAS, the index wins. It's more important than multiplication, so we do the index first. So we leave the multiplication for the time being and we evaluate -3 squared. That squared is only applying to this bracket, not the whole thing. Okay? If there were brackets here and here, then yes, it would apply to the whole thing, but there aren't. The squared only applies to this bracket. So -3 times -3 is +9. And we finish off by doing the multiplication 4 9s is 36. There we go. And that's BIDMAS and how to evaluate algebraic expressions.